Hello and welcome to the last section of our introduction to conics. This is going to cover hyperbolas, probably a shape you haven't seen. The goals for this lesson are to identify the key information from an equation that's already in standard form so that we can make a graph, and then turn that around, look at a graph, and write an equation, obviously in standard form. Some background information, just the most basic, like if you remember the unit circle, you could think of this as the unit hyperbola. And if we had x squared plus y squared equals 1, that would be a unit circle. So it's this negative that's messing things up. I tend to think of this as an inside-out circle because of that negative, so that instead of getting a unit circle in here, I get these outside, what they're called as branches. And you'll notice that the branches will be in the direction of the positive term. So this is horizontal because the x squared is positive. And likewise over here, because the y is positive, we get what I'll call an inside-out circle, or ellipse, I guess technically, that is vertical. All right, so that's the basic idea. Of course, we're going to get a little more complicated. The equation of hyperbola in standard form will look like one of these two. And again, the key here is that we're looking for the one that's positive, or the fact that there is a changing sign in the two terms. If we had a positive in between here so that the x and y terms were both positive, it would be an ellipse. But since we have negatives, we want to make sure we recognize it as this shape called the hyperbola. And key information for sketching the graph, the HK, the point HK is the center of the hyperbola. And technically, just like in a circle, the center is not actually part of the graph. It's just a very key point in making the drawing. Then we've got this plus and minus b over a. And if you look back at the equation, the b and the a are the stretches or shrinks. And we look at those numbers to determine the slopes of what are called asymptotes. And you know the vertical and horizontal asymptotes from other graphs. These are going to be diagonal. So that'll be a little bit tricky to draw those, and we use the b and the a to determine the slope on that. And then lastly, the direction that the branches go, we looked at already. They're going to go to whichever term is positive. Okay, so here's the general format that we want to look at. Let's look at a specific problem. So again, the h and the k are going to come from the numerator here in the x and y terms. In this case, x minus h is x minus 1, so we have a positive 1 and a negative 2 for a center. Remember, the asymptotes are slopes that come from the denominators, and we take the rise over run from those denominators. In this case, we'd have a plus and minus 4/3. We'll show you what that looks like on the graph on the next slide. And then last, will this have what we call branches that open up and down, or left and right? And looking at which term is positive, the x term is positive, so we would expect a horizontal set of branches. So here we go. Question 1 here. We're going to want to identify the center, draw our asymptotes. There's a little trick there with making a box, and then we'll draw our branches. The branches will open left and right, we can tell. So here we go. The center is going to be at -3, -1. And from there, we look at our denominators, in this case, a 1. So we're going to take the square root of 16. We want that inside of our equation, so that'll be a 4 and a 1. We, from our center, go up 4, right 1, down 4, right 1, and we can reflect those over. And this is a little box that we can use. Our graph will just touch this box. The actual graph I'll make in green opens horizontally along a, let's see here, an asymptote that looks like these. And so opening horizontally, we go that's not real good, but I hope you get the idea. Okay, with that, we've sketched our drawing, and you're going to want to label a few things. I'm going to want to know these, the center for sure, -3, -1, and the vertices would be nice. So my vertices, -2, -1, and -4, -1. Let's do the next one here. Again, this one doesn't have the slopes inside, so I'm going to take the square root of those denominators. Conveniently, they're perfect squares. So we plot our center again. Center at -2, 1. I'll go ahead and make the box first here. I go up and down 3 and left and right 2. And then make a dash line. This is not actually part of my graph. And now sketch the branches. This one's going to be left and right again. So you can put a dot there. Labeling these important points. The center is at -2, 1. And my two vertices are at, in this case, 0, 1, and -4, 1. All right, and now we're ready to do another one. The software throws the negative in the middle, and so in this case has the X written next. That means it's basically going to be a vertical branch type of hyperbola. But our center is going to be at 4, 0, and the slope is going to be, this is like an over 1, this is an over 4, if I put it inside the squared. So it's going to be up 4 over 1 and down 4 over 1. I'll make that little box. Okay. And our asymptotes here. Okay. And the graph will be, like we said, up and down. So up 4, put that dot there, and then this graph is going to look a lot like a parabola we're used to seeing. And those are vertices, obviously. And so my vertices exist at 4, 4, and -4. Sorry, 4, -4. All right. Try this number 4 on your own. Now working the other way, if we're given the graph, we want to write the equation. I think you may find that this is easier than the drawings, especially if you know the form that you need. And the form we need is going to have some squared stuff set equal to 1. We don't know if the x or the y is positive or negative yet, so we'll leave that. All right, my center, 0, 0. And the box shows the slope. Slope looks like it's 3 up and 4 over. So the over is the horizontal. and the up is the vertical, 3. And those are going to be positive and negative. We don't show that in the forms yet. But now it looks like the branches are vertical, meaning it's positive. That means the x term has to be negative. So there we go. Let's try another one. And you don't have to have the y or the x the first term, but it's kind of the way things typically are in math here. We use standard form to be the x and then the y. My center is right 2, down 2. Got to look at the scale here. So to move right 2, that means a minus 2. And then down 2 is going to be a plus 2 for the y. The slope looks like up 1 over 3. So the over is the horizontal, the up is the vertical. And then the branches opening up and down means the x is negative, the y is positive. There's our equation. And now we have another graph here. The branches are horizontal, looks like, so our negative will be with the y. Our equation will look again equal to 1. I'll put the x and the y. And the y is going to be the negative. X is positive, that's where the branch is. Our center looks like it's at 0, 1. So minus 0, minus 1. And then our slopes go up 1, 2, 3, 4, and over 4. So there we go. Try this next one on your own, and we will see you in class.